Very good morning to all, and I'm extremely sorry that I could not be there with you in Bangalore. Today's workshop on atmospheric satellite for monsoon cloud precipitation science and applications, Vasamsa 2022, is very important and need of the hour. The emphasis of the workshop is to make an assessment and evaluate our present understanding of cloud and precipitation system in the Asian monsoon region and to identify gap areas for further research recommendations. In order to improve our forecasting system at all time scales, we need to have a better observations, understanding, modeling, and forecasting system for the effective dissemination. According to me, there are three important factors that effectively improve our forecast. Firstly, observations. Both in situ and remote sensing are important not only to understand the process but also assimilate data for better initialization and provide accurate forecast. Presently, we are not having sufficient observation to simulate and forecast atmospheric variables, both space and time. It is imperative to have better and more in situ observations such as automatic weather stations, upper air observation using radio sonde, and remote sensing observations such as radars and satellites for better predictability. Hence, if we improve our observations, the forecast will be better in all time scales. Secondly, knowledge. We need to still understand many processes, especially cloud microphysics and its dynamics, and for that we need high resolution observations. We need more information regarding details of hydrometeors, its vertical distribution, and latent heat released by these hydrometeors. TRMM, GPM gave some information, but a lot more is needed. The observation is very sparse over the land as well as in the ocean, which affects models' ability to predict the diurnal cycle of convection vis-a-vis rainfall, and eventually error propagates in daily rain, weekly, as well as final seasonal forecast of monsoon rainfall. And hence, satellite data is crucial. Presently, most of the linear processes are incorporated in the existing forecast model, but the nonlinear processes still need to be understood and incorporated in the model for better forecast for both short term and long term. Most of the external forcing for monsoon forecast are implemented in the existing operational seasonal forecast model, but internal dynamics or forcings are yet to be understood and need to be included in the model. More efforts are required to improve the existing cloud parameterization. For this, we need much more observations such as aircraft KIPEX done by IITM and cloud physics data from high altitude stations like Mahabalipuram and other things. And most importantly, satellite data. Clouds are fundamental to water cycle in the atmosphere and dominate the energy budget of the planet. By modulating the distribution of heating within clouds, fundamentally influences the circulations of the atmosphere and oceans. Poorly resolved clouds, through their effects on the surface radiation budget, produce an unacceptable discrepancy in the implied atmospheric or oceanic transport of heat and mass as simulated by large number of climate models. Indian summer monsoon variability has been viewed as manifestation of vagaries of propagating mesoscale convective systems embedded in the tropical convergence zone. Clouds are important in modulating the global energy budget and hydrological cycle. Although considerable progress has been made, numerical models still struggle to accurately simulate the characteristics of clouds and their radiative effects. The uncertainties in modeling can be partially attributed to the poor representation of the cloud microphysical properties, in addition to those caused by cloud macrophysical properties. It is highly necessary to extend our knowledge of cloud microphysical properties. Prior to the launch of CloudSat or Calypso satellite, cloud microphysical properties were mainly obtained from passive sensors on board. The provided liquid or ice water path data in these products have been widely used for validating model performance in the past. In situ measurements and aircraft experiments are another way to acquire cloud microphysical properties. The disadvantage of these observations, however, is that they are sporadic and region dependent. By contrast, satellite provides cloud retrievals on a global scale and detects clouds layer by layer, which were inaccessible in earlier passive satellites. Over the past decade, CloudSat or Calypso have been widely used for cloud investigation and model evaluations. There were satellite missions in the past and cloud measurements like CloudSat, Megatropics. CloudSat carried the first spaceborne millimeter wavelength radar capable of jointly observing most of the cloud condensate and precipitation within its Nordic field of view. CloudSat provided cloud profile information, liquid and ice water content profiles and precipitation. The information is obtained by combining radar measurements with aqua measurements, including MODIS and AMSRE, as well as the Calypso LiDAR. Apart from observations and understanding, the third component which we need to improve or augment is high performance computing systems. We need high performance computing resources for higher resolution forecast and also for more ensemble members to reduce the uncertainty. Vasamsat 2022 aims at a satellite mission project to add new dimension to space-based observation, profiling cloud and precipitation simultaneously. So this workshop is a first kind of workshop on satellite missions and scientific projects program of India and international. I am sure that this workshop will discuss various observations, understanding, and how to improve new knowledge and incorporate the same into the model for better predictability. On behalf of Ministry of Earth Sciences, I wish the workshop a grand success. Thank you all.